Hey guys, what is up? Quackroy here. Today we are going to be talking a little bit more about pointers. Remember in the last tutorial we kind of talked about how memory was structured in a program, and we did a little experiment with showing the addresses of the various variables that we created. Today we're just going to be basically working with pointers and show some of the really simple things you can do with them and why they're useful. So let's go ahead and get started. First, we're just going to show, I believe I covered this a little bit in the functions tutorial, but we're just going to show basically a function where we take in an integer and we take in the integer by its value, which means if we pass some integer into this function, it'll be copied into this val variable, and then we cannot actually modify this val variable. So it's really good for something like printing. Say we want to, pass by value equals val, and we want to go ahead and do that. But say we want to actually modify this val. Say we want to perform some complex operation on it where we want to times it by a number or something like val equals val times 2. If we attempt to do this with this pass by value, it actually won't work. So let's go ahead and show that. So let's pass this foo in here, pass by value, foo, and let's go ahead and try and print it. After pass by value. And if you see, if we compile this and print it, we can see pass by value equals 10, which is in this function here. And then after we try and set it to a new one and return it, the value actually doesn't change. That's because we make a copy of this foo value. We add it to this function, so it's now stored in val, and any changes we have in this function scope doesn't actually change the value. So this is where pointers kind of come in handy. So let's create a new function, void f, and we're just going to create it. Instead of having an integer value, we're going to pass in an integer pointer. Now I went over pointers a little bit in the previous tutorial, but they basically point to the address, or they contain the address where that actual value is located. So if you think about it, if we pass in the address to this function, we're not passing in the actual value, but we're passing in a pointer to where we can access that value. So it doesn't matter where we change it in terms of scope, we can still access the location where that value is, so we can modify the actual value itself. So let's go ahead and show how that works. So let's create a new one called bar, and let's go ahead and do our f. And in order to create a pointer, we actually have to reference the address itself, so we use the ampersand for that. And let's go ahead and print it after f equals bar, and there we go. And let's go ahead and to really show this, I think we should actually be printing out the addresses as well. So let's see, how should we do this? Let's right before we pass in this bar, let's go ahead and print out the address of the pointer. So address in main equals, let's cast it to a long just so it's easy to look at. And then in here, we are going to print out the address here as well. Address in f equals, we just go ahead and just do pointer there. We're going to print out the value, and in order to access the value from a pointer, you have to do what's known as dereferencing the pointer. And in order to dereference a pointer, you just prepend the variable with an ampersand. Or not an ampersand, an asterisk, sorry. So you can see kind of some similarities, like this asterisk and this ampersand here are like the two main keywords. This usually means a reference, this means a pointer, and you can use this to dereference a pointer. And you can basically use an ampersand to reference the address of the variable itself. So I mentioned before that this doesn't actually change the value, but we can actually change the value in here by directly modifying the value of which this pointer points to. If that it's a little bit of a tongue twister, but basically we want to take this pointer, we want to dereference it to where the value is, and we want to set it to a new value. So this will actually change this variable here into 20, and I'll show that by printing it out. Let's go ahead and print the address and variable again to make sure that nothing crazy is happening. And as you can see, we are printing it here. So let's go ahead and compile this and run it and see what happens. Okay, so here's our pass by value. Here's our address in main. You see this 445, address in F, 0043. So something to notice is that these two addresses are actually different, even though we are referencing the same variable. That's totally okay. We just actually take a copy of the address when we pass it into here. So the pointer is still pointing to the same variable, it just has like a different address. So as you can see, address in F, or address in F here, and then the value in F is 10, of course, and then the address actually stays the same, but the value is actually changed. And then in this after F, you can see we have actually modified the underlying value. So that really shows, like, one of the really cool things you can do with pointers. You can actually change a value in a function. And there's another way to do it. You can also pass by reference, which we will be covering in the next tutorial. And another kind of cool thing that I figured I would show that kind of like really shows what I was talking about in the previous tutorial about global variables, how they're located very close to each other in memory, often like directly next to each other. So we're just going to do this little cool experiment. Let's go ahead and create, we're going to do A, B, and C, and we're going to set A to 10. And what we're going to do is we're going to get a pointer to B. So we're basically, we want to reference where B is stored in memory. So in order to do that, we do B pointer equals %B. So now we have set the value of A, this equals 10, and we have a reference to here. Now if you remember, A is actually stored 4 bytes before B in memory. And since we have a pointer to B in memory, we can actually change the value of A without directly setting it. So we can change this value by just manipulating pointers. So this is a very, very like strong and like interesting feature of C++ that isn't really available in something like Java. It's both dangerous and extremely powerful. Often you see many exploits like buffer overflows and things like that are due to referencing memory that you're not really supposed to. And what we're doing here is we're not really supposed to be modifying A, but we're still able to do that. And how you can do that is you can just use simple math arithmetic. So B pointer equals B pointer minus 1. What's this saying is it's going to basically take this B pointer, it's going to subtract the address. So 1, I believe it'll actually subtract 4 in the hex address, so it'll reference A, and then we can go ahead and actually modify this B pointer variable and set it to something new, since B pointer is now actually pointing to A after we subtracted 1 from it. Remember, it was pointing here, we subtracted 1, now it's pointing to A. So we can actually set that value. And let's go ahead and print out all the addresses to show that this has actually happened. So let's cast these to long, A and L, and let's do BC. And we should probably also print out B pointer. I think that's kind of important. B pointer, and to show that we've actually modified B pointer. Do it here, and for the final awesome thing, we're going to print out A to show that we've actually modified it without directly referencing it. So let's go ahead and compile it and run it. Okay, so let's see. We have our 3 variables here. We have 008. Let's see, what did I print out? A, B, and C. A, B, C. Okay, I printed out B pointer. So this is where pointer, let's go ahead and cast these to make it look a little bit the same. Okay, so we have B pointer, which is here. So this is, so if you see ABC, it's 96 is A, 500 is B, and 504 is C. So 500 is B here, and we subtracted 1. So we actually have the reference, the same address as A, because we subtracted here from that pointer. And C, we actually set the value to 20. So we didn't actually modify what was in B, we actually modified what was in A, because you see A is now 20 from here. So that's a little bit of a cool thing you can do. Both you might do it on purpose. Oftentimes if you're dealing with something like character arrays, you might do it by accident and get segmentation faults and things like that. But yeah, I think that pretty much shows some basic cool stuff you can do with pointers. That's it for this tutorial. The next one will most likely be on references. Make sure to subscribe and stay tuned for more C++ tutorials. This is Quackverse signing out.